this is a calm and peaceful scene. But sometimes, storms that develop way out there in the ocean can cause havoc on land. These storms can cause massive flooding in coastal areas. And the winds that accompany these storms can move at a speed of 200 kilometers per hour, which is as fast as Formula One cars. Today I am in Sri Lanka, a small island to the south of India, to talk about major storms that develop way out there in the ocean. By the way, Sri Lanka is sometimes also called a tropical country. To understand the meaning of that word, let's look at this map. People who love maps draw these two imaginary lines on them, Tropic of Cancer and Tropic of Capricorn. The region in between these two lines and around the equator is called the tropics. India and Sri Lanka are both in this tropical zone. Now, one really interesting thing about this region is that it has warm ocean waters. Another really important thing is that this region also has some incredible storms that begin way out there in the ocean. This is all of the major storms between 1985 and 2005 that started in the ocean. We call these storms by different names. Cyclones in India, Sri Lanka and Bangladesh, typhoons in Philippines, Taiwan and Japan, and hurricanes in America. Let's begin by thinking about the word cyclone. Now, when I look at the word cyclone, I think of a cycle and its wheel, and how it goes around in a loop, again and again and again. I want you to put a pin in this thought. We will soon see that cyclones are also a form of loop. Cyclones get their energy from the warm ocean water. This water evaporates into vapor. By the way, that process takes energy, in much the same way as it takes energy to boil water at your home. Now, this water vapor, which is filled with energy, rises up. You may have seen examples of warm air rising in hot air balloons, candle lanterns, and steam from a pressure cooker. Anyhow, at this point, our textbook says the following about this rising warm air. It says that the air tends to rise and cause a drop in pressure. Now, frankly, this statement was really hard for me to understand. What this really means is that as the air moves up and away from the surface, there is less air left near the surface. And less air just means low pressure. Another way you can think of this is by imagining a train. Think of a train when there are a lot of people in it. Now, the tension and mental pressure on everyone in the train would be high, as a lot of people are really close to each other. This is similar to a situation where a lot of air molecules are packed closely together. That situation creates high air pressure. On the flip side, when there are only a few people in the train, everyone is comfortable and relaxed and has low mental pressure. This is similar to a circumstance where only a few air molecules are packed closely together, and thus the air has low pressure. So when the air evaporates from the surface of the ocean, there is less air left at the surface, therefore fewer air molecules, and thus the air has low air pressure. Now, as the evaporated moist air rises, it cools off, and the water in the air forms clouds and condenses back into a liquid. This process, by the way, gives off energy that was stored in the air. This energy is released into the atmosphere, which causes more water to evaporate from the ocean. And that is where this whole process becomes a loop. Let's watch the action replay of this loop. Water from the warm ocean evaporates. That takes energy. It rises, cools, and condenses, or turns into a cloud and liquid. That gives off energy. That energy heats up the air, causing more water to evaporate. And that loop continues. This whole system of clouds and wind grows and starts to spin. And we measure the speed at which the winds move in a storm to give it different names. For instance, if the speed of wind is between 119 and 153 kilometers per hour, we call it a Category 1 cyclone. Here are the rest of the categories, with Category 5 being the most devastating. Now, the loop of a cyclone breaks when it hits land. This is because once they're on land, the source of energy, which is the moist air from the ocean, is no longer available to power the cyclone. However, before they die out, they can do a lot of damage. They can cause massive flooding and rain in coastal areas. So we now know how these massive storms cook themselves in the ocean. Today, however, is a calm and enjoyable day. For now, I will go back to this peaceful view. We want to thank the Google's Making in Science team for sponsoring this video. You can check out other great content at #ScienceGoals.